Welcome to my channel. In this video, we are going to learn the basics of electricity. I am going to discuss few basic fundamentals like electric charge, potential difference, electric current, etc. To begin with, what is electricity? It is an important source of energy and has an important place in the modern society. It is controllable and convenient form of energy for a variety of uses. For example, we use them in our homes, schools, hospitals, etc. for lighting and fans, etc. In industries, to run machines. In transport, to pull electric trains. These are few examples. So we know that we cannot imagine our life without electricity. So now let us consider certain basics. So to begin with, electric charge. If you take a comb and bring it to near to tiny pieces of paper, it won't attract. But if the same comb, if you rub it with dry hair, the comb gets electrically charged up. And then if you bring that electrically charged comb, it exerts electric force and attracts those tiny pieces of paper. Now there are two types of charges. So now I will represent the charge usually with Q, and we can also represent eventually E, we will see. So there are two types of charges, positive charge, examples like protons, negative charges, electrons. So usually charge is also represented with E because mostly negative charges, electrons move. Now what are the properties of these charges? Opposite charges attract each other. That means if you have a positive charge and a negative charge, they attract each other. But similar charges, positive and positive, they repel each other. So they repel each other. The SI unit of a charge is Coulomb, represented as C. Now what is the definition of this Coulomb? 1 Coulomb is that quantity of charge. So it is a quantity of charge which exerts a force. So I said it exerts a electric force, which exerts a force of 9 into 10 power 9 newtons on an equal charge placed at a distance of 1 meter from it. So that is the definition for 1 Coulomb. Usually it is denoted with the letter C. Now charge of a proton is 1.6 into 10 to the power of minus 19 coulombs. We usually write it as plus E. And charge of an electron is minus 1.6 into 10 to the power of minus 19 coulombs. We will represent it as minus E. Thus Coulomb is much bigger than the charge of proton or neutron. As you can see, 1 Coulomb is much bigger than 1.6 into 10 to the power of minus 19 coulombs. That is the charge of either proton or electron, either depending on plus or minus. Now, we can write this expression. See, Q is equal to NE, charge is equal to NE, where N is Q by E. So what is this equation representing? Charge contained in these many electrons. So how many electrons? So 1 Coulomb of charge is equivalent to 6.25 into 10 to the power of 18 electrons. How do we get that? So the number of electrons in 1 Coulomb of charge. So how do I calculate? Number of electrons, N is equal to Q is 1 Coulomb by charge E is 1.6 into 10 to the power of minus 19 coulombs. So that is 6.25 into 10 to the power of 18 electrons. Now this flow of charges is electricity, flow of charges, but usually positive charge protons, being heavy mass, usually they don't move. So, most of the times the electrons are the charges which move, and we will discuss it. Substances through which electricity can flow, where you have free charges, are called conductors. They are also called as metals. Examples like silver, copper, aluminum, etc. Substances through which electricity cannot flow are called insulators. Insulators, that means there are no free electrons, and in conductors you have free electrons. That means if you consider a conducting material like this, then the charges will be freely moving inside a conductor, where you don't have the free electrons to move in insulators. Now, to broadly classify electricity, we have two categories: static electricity and current electricity. Now, charges at rest. Static means at rest, that means there is no motion. So, charges are at rest, there is no movement of charges. Example like lightning in the sky during rainy season. Now, current electricity is when you have charges set into motion. So, charges are moving. So, moving charges. A study of moving charges is what is current electricity. This electricity is the one which we use in our homes and all other domestic purposes. Now, let us try to understand what is electric potential. Now, let us say I have a point A. I have a point A, and this is point infinity, far off. Now, if a unit positive charge is to be brought here to the point A, then there has to be some work done against force of attraction, force of repulsion, against force of repulsion, and work has to be done against force of repulsion, and this unit positive charge is moved from infinity to the point A. So, to the point A. So, work done in moving a unit positive charge from infinity to that point A, denoted by the letter V. So, potential is denoted by the letter V, and I can write this potential at this point. Let us say I represent it as VA, and then I represent this as V infinity at this point. Then this point, potential at infinity is 0. Potential at infinity is 0. So, let us see the definition. The electric potential at a point in an electric field is defined as work done in moving a unit positive charge from infinity to that point. A unit positive charge moving from infinity to this point A. So, work done in moving a positive charge. So, a potential of the unit is volt, which means a potential of 1 volt means 1 joule of work done in moving 1 coulomb of positive charge. So, 1 volt is 1 joule by 1 coulomb. So, the next important is potential difference. Now, let us consider 2 points A and B. 2 points A and B. Now, if a positive charge, a unit positive charge is moved from point A to point B, point A to point B. Now, let me write the potential at A as VA and potential at B as VB. Then, the difference in this potential the difference in the electric potential between these 2 points A and B is known as potential difference. So, I will represent, this can be represented as PD, I will represent this as delta V, the potential difference, delta V, difference between the potential between the 2 points, and that will be final is at the point B. So, VB minus VA. So, this is VB is the potential at the final point and VA is the potential at the starting point, that is the initial point. So, VB minus VA, delta VB, delta V is equal to VB minus VA, and what is this equal to? Work done. So, here work done in moving the charge. So, quantity of charge moved, quantity of charge moved. So, SI unit, again this unit, so let us see the definition once. It is the amount of work done in moving a unit charge from one point to other point. Let us say I take a conductor like this. So, from this point to this point, if I consider A and B, then the work done in moving this positive charge Q from point A to point B, then that difference between these 2 points is potential difference. So, it is the amount, so work has to be done. So, it is the amount of work done in moving a unit charge from one point to the other point, or the difference in electric potential between the 2 points. It is basically the electric potential difference between the 2 points. That means the electric potential at A and electric potential at B. According to potential, we have the definition work done in moving a unit charge. So, we have equated this to this. So, I can write this as 1 volt is equal to W by Q, volt is W by Q, and W is 1 joule by 1 positive charge is a 1 coulomb. So, that is 1 joule coulomb inverse. So, it is measured, this potential difference is measured between the 2 points using a voltmeter in parallel. So, this is how it is measured, in parallel using voltmeter. This potential difference can also be called as voltage between these 2 points. So, you can measure, this is point A and point B, this can be a conductor. So, I am representing with a symbol resistor, we will discuss that later. So, using a voltmeter is always used in parallel to the conductor. So, in parallel to the conductor, and a voltmeter has a high resistance. Voltmeter has a high resistance, so that it takes negligible current from the circuit. High resistance means it will not be allowing the current to flow, the charges cannot flow. Therefore, negligible current flows, negligible current flows in the circuit. And the next important parameter is electric current, I. It is the potential difference between the ends of a wire which makes electric charges to flow in the wire. Basically, current is, therefore, it is defined as the flow of electric charges in a conductor in unit time. Just like, for example, you understand, just like speed. Speed is distance by time. Here it is the speed of charge which is moving in unit time. That means it can also be said as rate of flow of charge. So, you can also call this as rate of flow of charge, rate of flow of charge. So, if Q coulombs of charge flows in 1 second, then I is equal to charge by time. That time is 1 second. So the SI unit is ampere. So this is coulomb, this is second. So 1 ampere is 1 coulomb by 1 second. Now, how does this happen? Now, we all know that if I consider these two, we will know that these two, water is there, for example, at same level, and I connect a pipe between them. Because the water is at the same level, there is no water flow. There is no water flow. But if I consider the water is removed from one of the beakers, so I reduce the water in this one to this level, so there is a potential difference. So there is a difference of level. So there is a pressure difference, and therefore water will flow, and this water will flow because of this pressure difference from higher level to lower level. Similarly, if you create an electrical pressure difference through a potential difference maintained, then charges will flow. Charges will flow from a higher potential to a lower potential, and that continuous flow of charges through a potential difference, and this potential difference can be generated using a cell or collection of cells. We call it as battery. So how can you generate that? If it is a conductor, then electrons will be random. Then you connect it to a battery or a cell. So what will happen? The electrons are attracted towards the positive terminal, and electrons will be repelling. So the current will be flowing from, so the electrons will have a directional motion like this. So being random, because of this battery creates a potential difference. It does the work. This battery does the work in creating this potential difference. So what will happen? What is exactly a battery? A battery is like this. So there will be chemicals, and therefore all the positive charges and electrons will be repelled. So you have a negative charge here, you have a positive charge here. So there is a potential difference created, and this potential difference generated by the battery sets the charges in motion, and that creates a current. Now the electrons will be moving in this direction, and the actual current, conventional current, will be opposite to the direction of electrons. See, actual current is from higher potential to lower potential. Positive is higher and negative is lower. So the current will be flowing like this. So from positive to like this, negative. So current direction is opposite to the direction of electrons. So the direction of electrons is opposite to the conventional current. I, which is positive to negative, So there has to be a potential difference which creates that electric pressure. Therefore the charges are set into motion, and that creates the electric current, and this current is measured in amperes, and this current can be measured using an ammeter in series with a conductor. So this is an ammeter, and Usually you can measure microamperes or milliamperes and using this ammeter in series. So an ammeter is used to measure current which is used in series, which is always used in series, so that the entire current passes through it, because it will have low resistance. Now this current does not depend on the area of cross section of this conductor. It does not depend on, it depends only on how much charge is flowing in a given time. So that is rate of flow of charge. So how do we define ampere then? So we will define ampere when 1 coulomb of charge flows through a conductor in 1 second, then the current is said to be 1 ampere. So I will write 1 ampere. So usually we can write 1 ampere. Now in my next video we will discuss, using this concept of electric current, potential difference and all, we will discuss Ohm's law, which is very important concept. Until then, keep watching, keep learning. Thank you.